guys, and welcome back to a new video. In today's video I will show you everything you need to know about the Java local date time API, which is the preferred API you should use if you need to deal with the dates in Android. The reason I recommend that is that it just works so intuitively. So you really don't need to learn a lot. It doesn't have a steep learning curve to understand how you can use it to just deal with dates, manipulate dates, add days, add years, how you can calculate stuff with time, how you can combine these, how you can deal with time zones. All that is stuff that I will show you in this video, so you are then settled, because dates and date time stuff is really something you need in pretty much every app out there. And we won't be building anything in particular here in this video, but I will just go through what we can actually do with our local date objects, local time, local date time, zone date time, and what is all out there. And I will show you, just what kind of possibilities we have with these kind of classes. And I want to start here in my empty compose project with simply creating a date field. So val date, and we just set that to member, and we say local date. You can see we have local date, we have local time, and we have local date time. What is this now actually used for? All these local times, local date times, they actually just reflect, as the name says, a local date or a local time of the user. They don't contain any time zone information. So imagine you are building a node app, and each node has some kind of field that displays at which day that node was actually added. And that is a purely local app. Then you are totally fine to use these local date objects here to show the date of a node. For example, we can say local date.now, which just refers to the current date. And you can also see that we get a little error here. If we hover over this, this call requires API level 26. Current minimum is 24. However, we can kind of bypass this by adding a dependency in our build.gradle app file, scrolling down and passing or pasting this stuff here, this core library desugaring. You can find this kind of dependency down below in the description, or you can simply write it off here. And we also want to then scroll up, go to compile options, and say core library desugaring enabled, and set that to true. By doing that, we just simply achieve that the minimum SDK this local date time API needs is, I think, it goes down to 21 or so. You can see the error goes away, even though we didn't change our minimum SDK. But before we go on, there is still an ongoing course launch active on my website where you can get 25% discount on all my courses, including the bundles. So even on top of that bundle discount, you can get an additional 25% off using the discount code KMM25. So if you want to learn how you can build Android and iOS apps using your favorite language, Kotlin, or you want to learn something from my other premium courses, then check the first link in this video's description and also claim your limited bonus section. And now let's get back to the video. And we can now simply create a box to simply, let's say we want to display our date in our UI, fill the whole size of our screen, center our stuff here, and we can then say we have a text that displays our date, that toString. And if we then launch this, taking a look at my device right here, let's see, and you can see there is our current date, November 1st, and that is working perfectly fine. But let's now see what we can do with this local date API. So after we actually created such a date with a local date, now we could do some kind of date math. So on the one hand, you can see we can refer to the day of month, which would simply be 1 in this case, because it's November 1st. We have the day of week, which would be, I think it starts at 1. So today is Tuesday, I think. Yes, it is Tuesday. And that would then refer to, the day of week. We can launch this, see what it does. And you can see Tuesday. Oh, I was actually right. And what else can we do? We could also do something like day of year, which is, well, I can't tell you that, but Android can. So that, we now have the 305th day of this year. And a lot of this cool stuff. But let's see what else we can do. Let's leave these out for now. That return a local date time and zone date time. We will get to that later. But what's interesting is all these functions here, minus days, minus months, weeks, years, plus days. So that is how we can now very easily do date math. So if you want to add, let's say, 13 days from today, and you want to retrieve the final date of that, you can say plus days 13, and you can then simply launch this app, and you will see, okay, now you get November 14th. Cool. So let's actually take a look at the next kind of concept, which is very similar, which is local time. So local time, and we can also say local time.now. This time we of course don't have plus days because we can't add a day to some kind of time, because local time now just refers to a combination of hour and minutes. And it also contains information about like milliseconds, nanoseconds and stuff like that. But if we just leave it like this, local time.now, launch this, then what we see is exactly that. So it is 19:53, 18 seconds and some milliseconds, which you can now also use to do some kind of math with. So we could say, either refer to the hour, minute, nano to the seconds, but we can also say plus hours, for example, plus 50 hours, and we then relaunch this, then we will see, okay, now that is actually the time when we add 50 hours to our current time. So we can do a bunch of cool math with that as well. Let's see what else we got. Of course, also minus. We have is after, is before. If we have two times that we can compare these, we can also simply use the comparison operator here in Kotlin for that. I think there's not too much anymore that's really interesting. What you could use is add 2 nano of day, 2 second of day, but yeah, that will simply return how many seconds that day lasts, I think. That's something interesting here, of course, 2 epoch second. That's something you need very often to actually convert a date or a time to a certain timestamp. But since we only deal with the local dates here and local times, they don't contain any information about a certain timestamp, because a timestamp needs to be universal. It needs to be the same kind of time for anybody on this planet. So in the end, what I'm trying to say is that needs to contain information about time zone, which a local time and a local data object do not. We will get to this later here, but now that we understood local date and local time, we can get to local date time, which is the combination of these two. So we can say local date time.now, for example, relaunch this and take a look. Then we now, just get a combination of a date and a certain time. So when is each of these actually needed in an actual app? Starting with a local date, that is really only needed if you just care about a certain date. For example, if the user needs to select their own birthday or so, then you don't really care about the time when the user was born, you really only care about the date. So in that case, local date would be the right type to use here. If you, for example, want to build some kind of clock or so, so you only want to show a clock, maybe it was kind of custom circular clock or so that you display in your app, then you could use a local time, because all you care about is displaying time without any additional date information. So in that case, local time would be the right type to use. And if you actually need both these informations, so if you need the date and the time, you need to use local datetime. For example, if you were to build a calendar app where you can create some kind of events and you want to set a reminder for each event, then local datetime would be the right type to use here, because an event would trigger at a certain date at a certain time. So then you would use local datetime. And in my experience, that is also the type that you need the most here of these three. Let's see what we can do with these. It's in the end just a combination of local date and local time. You can see we can refer to all these fields. We can also refer to at local date and local time separately. We can also add days, add hours, subtract them. We can, let's see what else. Yeah, that's pretty much it. We can also have these is after, is before. If a certain unit is supported, we can also convert these to epoch seconds. If we provide time zone information, we can also convert these to local dates again and to local times. And we can calculate how long it is until a certain other local date time, which might be quite helpful. So if you want to calculate the difference between two local date time objects. And what you can also do is with local date time, we can say, so here are just different ways how we could create that. I used now, but you can also use off, for example, and here you can then just pass the year, for example, to 2022. We can use the month 11, day of month, today is the 1st, and the hour would be, let's say it's 20 now, and the minute would be 14 right now. So that's also a way how we could construct such an object. But let's see what else works. We can also say off epoch second. So if we have a timestamp in seconds, we can create our local date time object again with time zone information. And this one here is interesting, parse. So this will take a time string in a typical format, something like this. And that is something you very often get from remote APIs. So something like that is often contained in a JSON response. And of course, you don't want to deal with such strings in your app. So what you would instead do is you would have some kind of mapper in your data layer, which takes the string you get from the API and maps that to a local date time object. And then in here, you can simply say local date time.parse and pass in that date string that you actually extracted from your API. And then you already have this local date time object, which is a lot more convenient to work with than such a date string. Well, let's now get to the last type I always tease it here a little bit, and that is zoned date time. Because as I said, till now, we did not include any time zone information. But let's say you are building some kind of video calling app, and you want to kind of schedule a call with someone else who might not live in your country. Then you need to make sure that both these parties, you and the other person, are actually talking about the same time. So that's where you can't deal with local date time objects anymore, because you're not dealing with local times anymore. Since both these users who are scheduling the call could have different local times. So now you actually need to use zone date time. And we can also construct a zone datetime object similar to how we did this with local datetime. So zone datetime.now, that also works. But this now contains time zone information. And if we say that now, then we just refer to our own time zone. So if we print this, take a look here, then you can see it also includes this time zone information now, which in my case is just, Europe Berlin. And in your case, it will likely be something else. So now we really have a time value that anybody can do something with. Because we say, hey, at this date, at this time, using this time zone. And now we can also use this in combination with timestamps, or we can convert this to a timestamp rather. So we can say 2 epoch second, for example, times 1,000, and then we would get the current timestamp in milliseconds. So if you take a look here, then won't surprise you, that is something we very often deal with, for example, to save this in a room database, or to, that's also a different way of how an API might tell you a certain date and a time, because such a timestamp is just the value or the amount of milliseconds, I think, since 1970 or so. And with that, you can, of course, construct a unique date and time combination. If you have such a timestamp and you want to parse that into such a zone date time object, you can instead do something like zone date time dot off instant. That is how we can construct this with a timestamp. And in here, we can say instant dot off epoch milli or off epoch second, depending on what kind of timestamp you use. If you use a millisecond timestamp, you could pass that in here, for example, system current time millis. And then as a second parameter, we need to pass a zone ID, which just contains our time zone information. So we can say zone ID system default, for example, which just refers to the system default. And then if we launch this on my device, take a look here, then we get the same type of time here again as we did before. And if we would pass a different time zone here, for example, zone ID dot off, here we can pass a zone ID. So zone ID would, for example, be Europe Berlin, or we could pass Asia Tokyo, for example. That should work. If we launch this, then we see a different time now, Asia Tokyo time. And that's, of course, now, not my current local time anymore, which would be 8:20 p.m. Instead, here it's 4:20 p.m. in Tokyo. And if you understood all these differences between like local date, local time, local datetime, zone datetime, then you're really settled to use this API. So the rest is really intuitive. Of course, there are a bunch of functions I didn't show you here, but they really tell you everything you need to know. So here we could again parse a certain string into a zone datetime object. We could also say now, and then just do the same kind of math with, in this case, just a zone datetime object. So just as a little recap, local date just refers to a local date of the user, nothing that is shared with any other users on this planet. Local time, the same just for time. Then we have local datetime, which is also not shared with anyone else, but it contains a combination of date and time. And then we have the zone datetime object, which just contains time zone information. So as soon as you work with other users and you need to refer to the same kind of time object, and your users might live on different continents, then you need to use a zone datetime object to actually parse your time properly. And as a last thing, something you always need to do is, of course, to format times. That is something I haven't shown you yet. And for that, we have a special date time formatter. So if we say we have our zoned date time now, then we could say, well, formatted date, or formatted date time rather. And that is equal to remember. And we pass in, or we rather create our date time formatter here. We can say of pattern to pass a certain pattern we want to format this to. For example, DDD to just specify our day as a 3-letter format. We could then specify the month with 2 capital M's. We could then say we want the year as a 4-figure number. And we can say we want the hours and the minutes and the seconds. And if we then say, okay, that format, and we pass in our date, we take our formatted datetime and pass it in here. We then actually don't need this toString anymore. We can launch this and take a look. It crashes probably because the pattern wasn't correct. I don't have this in my mind every time. What's the issue here? Too many pattern letters for D. Okay, I just quickly researched. It is actually an E if we want the day to be written out. So we could say EEE and then DD to, yeah, you will see what this does. If we take a look here, you can see now we have Tuesday, November 1st, like kind of reversed here to 2022 and our current time. And with that, you really know pretty much everything you need to know about dates and times in Android, in any kind of Kotlin or Java project, and that's really something I need in pretty much every project I work at. So if you enjoyed this video and you actually want to see more regular Android videos, then definitely consider subscribing down below. And apart from that, I wish you an excellent rest of the week, and I'll see you back in the next video. Bye bye.